Hello everyone, welcome back to the channel. In modern electronics and robotics, motion sensing plays a very important role. Whether it's robots, drones, smartphones, or smart IoT devices, they all rely on sensors that can understand movement and rotation accurately. And in today's video, we are going to talk about one of the most popular motion sensors used in electronics projects, the MPU6050. The MPU6050 is a powerful motion tracking sensor that integrates two sensors on a single chip, a 3-axis accelerometer and a 3-axis gyroscope. The accelerometer helps us understand the orientation and tilt of an object, while the gyroscope tells us how fast the object is rotating around each axis. By combining data from both these sensors, we can accurately measure motion, balance, and orientation. That's why the MPU6050 is widely used in robots, self-balancing systems, gesture-controlled projects, gaming controllers, and drones. In this video, we will break down how both on-chip sensors work, understand their outputs, and see how they are used in real-world electronics and robotics projects. Let's get started and explore motion sensing with the MPU6050. The MPU6050 is a motion tracking sensor that combines two sensors on a single chip, a 3-axis accelerometer and a 3-axis gyroscope. Both sensors are based on MEMS technology. The accelerometer measures acceleration forces acting on the sensor, including gravity and movement. Inside the accelerometer, a tiny mass shifts when the sensor is tilted or moved. This change is converted into an electrical signal, which allows us to determine the orientation and tilt of the sensor. The gyroscope measures angular velocity, which means how fast the sensor is rotating around an axis. It uses a vibrating structure inside the chip, and rotation creates a force that is detected and converted into data. The accelerometer provides stable orientation data, while the gyroscope provides smooth rotation data. By combining both sensor outputs, we get accurate and reliable motion information. That's why the MPU6050 is widely used in robots, drones, self-balancing systems, and motion-based projects. Now let's connect the MPU6050 with the ESP32. The MPU6050 communicates using the I2C protocol, so we only need 4 connections. Connect VCC of the MPU6050 to 3.3 volts of the ESP32 and connect GND to ground. Next, connect SDA to GPIO 21 and SCL to GPIO 22 on the ESP32. These are the default I2C pins for the ESP32. Once the connections are done, the sensor is ready to communicate with the ESP32. That's it for the hardware connections. We include the required libraries. The wire library is used for I2C communication, and the MPU6050 library allows us to easily communicate with the sensor and read its data. Next, we create an MPU6050 object. This object represents our sensor and will be used to initialize it and read values from it. Inside the setup function, we start the serial communication at a baud rate of 111/5200. This allows us to see the sensor data on the serial monitor. After that, we initialize I2C communication using the wire.begin function. Here, GPIO 21 is used as SDA, and GPIO 22 is used as SCL, which are the default I2C pins for the ESP32. Now, we initialize the MPU6050 sensor using the initialize function. Once the sensor is initialized, we check whether the connection is successful. If the sensor is detected properly, we print a confirmation message on the serial monitor. Now let's move to the loop function, where the actual sensor reading happens. Here, we declare 6 16-bit integer variables. The first 3 variables store accelerometer data along the X, Y, and Z axes, and the next 3 variables store gyroscope data along the X, Y, and Z axes. Using the getMotion6 function, we read all 6 values from the MPU6050 in a single call. This function updates the accelerometer and gyroscope variables with real-time sensor data. Next, we print the accelerometer values on the serial monitor. These values represent raw acceleration data along the X, Y, and Z axes. After that, we print the gyroscope values. These values represent the raw angular velocity data, which tells us how fast the sensor is rotating around each axis. Finally, we add a small delay of 500 milliseconds. This slows down the output so the values are easier to read and understand on the serial monitor. Now that we understand the code, let's upload it to the ESP32. Before uploading, make sure you select the correct board. Go to the Tools menu, select ESP32 Dev Module or the specific ESP32 board you are using. Next, select the correct COM port from the port menu. Once the board and port are selected, click on the Upload button. After the code is successfully uploaded, open the serial monitor. Set the baud rate of the serial monitor to 1/5200, which matches the baud rate defined in the code. Now you can see the output coming from the MPU6050. Here, the values labeled Accel X, Y, and Z represent the accelerometer readings along each axis. When the sensor is kept flat, you will notice that the Z-axis value is high because it is measuring the force of gravity. As you tilt the sensor, the X and Y values start changing, which shows how the orientation of the sensor is changing. Next, the values labeled Gyro X, Y, and Z represent the gyroscope readings. These values change when you rotate the sensor, and they indicate how fast the sensor is rotating around each axis. If you move the sensor slowly, the gyroscope values change gradually. If you rotate it quickly, the values change more sharply. This live change in values confirms that both the accelerometer and the gyroscope inside the MPU6050 are working correctly. In the next part of the video, we will convert these raw values into real-world units and use them to calculate angles for practical projects. Motion-based applications. It is commonly used in robots for balance and orientation control. In drones, it helps with motion stabilization. It is also used in gaming controllers and smartphones for motion and gesture sensing. Because it combines an accelerometer and a gyroscope on a single chip, the MPU6050 is ideal for compact and low-cost motion sensing projects. That's it for this video on the MPU6050. We learned how it works, how to connect it with the ESP32, and how to read accelerometer and gyroscope data. If you found this video helpful, don't forget to like, share, and subscribe to the channel. In the next video, we'll use this sensor to calculate angles and build a practical project. Thanks for watching, and I'll see you in the next one.